This lesson deals with simple polygons and the interior and exterior angles of them. A simple polygon has sides made of segments. The sides are always straight and never curved. The endpoints connect at vertices. A vertex can connect only 2 points. That one's important. Only 2 sides. Segments that connect opposite vertices are diagonals. If one side is extended, an external angle is created between that side and the adjacent side. So let's see images between polygons and not polygons to determine the difference. So each of these 3 shapes are polygons because they're made up of segments only, straight lines only, not curved, and each vertex, each corner is made up of only 2 segments. Each of these 4 are not polygons. This one is not because it is curved, same as this one. This one is not because this vertice has 4 segments. This one is not because they don't connect. That vertice only has 1 segment. So let's look at these next 5 words to determine how they look. So the first 2 are convex and concave. Convex means that all the vertices are on the outside. There's no dents. So each corner is on the outside. Concave means that there are dents, that there's caves created. So there's a cave that's created between these 2 here. Or as in a star, there's a dent between here. Those are concave polygons. Equilateral is a term we've already learned. It's where all sides are congruent, such as an equilateral triangle. This can be a square or a rhombus. Equiangular means all 4 angles are congruent. An example could be a rectangle, because each angle is 90 degrees. But regular means that all sides and angles are congruent, such as a square. All angles are 90 and all sides are the same. So now we're going to take a look at these 8 shapes, and determine the number of sides, the interior angle sum, the measure of each interior angle, and the measure of each exterior angle. These are all if they are regular, meaning that all the sides and angles are congruent. First is a triangle. It has 3 sides. The interior angles add up to 180 degrees. Each angle, so if you did 180 divided by 3, that gives you 60. That's each interior is 60. Now to find the exterior to be 120. If a straight line makes 180, then 180 minus 60 is 120. That's how we're going to solve to find each of the interior and exterior angles for all 8 of these shapes. The next is a quadrilateral. 4 sides, 360 interior angle sum. Each interior is 90 degrees. Therefore, each exterior is also 90 degrees. A pentagon has 5 sides. It adds up to 540 degrees. Each interior is 108 degrees. Therefore, each exterior is 72. Next is the hexagon. 6 sides, 720 degrees for the sum. Each interior is 120 degrees. Therefore, each exterior is 60 degrees. We can see that each exterior is going each exterior is going down as each interior goes up. Heptagon has 7 sides, 900 degrees for the interior sum. Each interior is 128.6. Therefore, each exterior is 51.4. Next is an octagon, which is 8 sides. Each the total interior sum is 1080 degrees. Each interior is 135. Therefore, each exterior is 45. Next is the nonagon, 9 sides, 1260 degrees for the sum. If you do 1260 degrees divided by 9, you get that each one is 140 degrees. Therefore, each exterior is only 40. And finally is a decagon, 10 sides. If each interior is 144 degrees, how much is the total sum of the inside? 1440 degrees. And therefore each exterior is 36 degrees. Let's go ahead and fill in this chart just to kind of organize our data. I need to fix this on my sheet. I believe it is fixed on yours. We have the names already down. And just over here where it says anagon, this is for kind of the formula depending on what number of sides you have. So you can see a triangle has 3, quadrilateral has 4, octagon has 8, therefore anagon has n number of sides. So fixing this, triangle has 0 diagonals, quadrilateral has 2, pentagon has 5, hexagon has 9. For anagon, I'm going to write in the formula. The formula is n times n minus 3 divided by 2. Use this formula to find the answer for a heptagon. How many diagonals will it have? It will have 14, while an octagon will have 20. So I'm going to fill in the rest of the table. So here are the sum of the interior angles. The equation to find out, no matter how many shapes it has, is 180 times the number of sides minus 2. You can go ahead and try that for any shape to see if it works. So each interior angle of a regular polygon is listed. For the anagon, no matter what sides, it is 180 times n minus 2, just like the sum of the interior, except we're dividing it by the number of sides. Now each exterior of a regular is shown. This equation may be one of the easier ones to memorize because it is only 360 divided by n. You will need to memorize these formulas because you may get a question that says, how much is each exterior of a 20-sided shape? So, for example, you would just do 360 divided by 20 to find your answer. So, your homework for tonight is to finish these problems down here. Use those formulas to help you solve each problem. There should be no reason to not get them all done.